let's start this class. Yeah, today we will continue to talk about the Fourier series properties. And actually, after today, yeah, we finish the chapter 3. Yeah, so I will do a midterm 3 like a review on Friday, and we will have an exam next week. Yeah, midterm 3. Do you think which day is a better day for you? Monday, Wednesday, Friday?
Friday.
You mean the next Friday?
Either Wednesday or Friday next week. Definitely not Monday.
Okay, got it. Okay, yeah, let me decide it. Yeah. Okay, let's continue to talk about the Fourier series property. And yeah, this is another class for the chapter 3. And first, let's talk about this goal. Yeah, we will quickly review the symmetric properties, linearity and time shifting properties, differentiation, integration properties, and the multiplication properties of fs, and use them to simplify fs computation. We talk about multiplication properties in last class. Yeah, and we will talk more examples for that. And you can see all these properties, actually, there is just one purpose, help us to simplify the fs computation. Yeah, help you to easily to find the fs coefficient. Yeah, if you have the fs coefficient, you can easily to use the signal synthesis equations to get the signals. That makes sense to you? Yeah. Okay, and then after this, we will study the time reversal, time scaling, and the conjugate properties, and apply these properties to simplify the computation of fs coefficients. Yeah, those are all the properties for the fs fs coefficient. Yeah. Okay. Let's try to review the symmetric properties. Yeah, for the symmetric properties, we know for the real signals, what's the relationship between the what's the properties for the fs coefficient? Do you remember? Yeah, that's include to the, but for the real signal, we have a key equal a negative key conjugate. Yeah. Okay. And we call it a conjugate symmetric. And for the time reversal, what what you can get for the fs coefficient? Do you remember? Yeah, the b key equal a negative key. Yeah, you don't need to remember it, but you need to know that. Yeah, and actually, yeah, for the even signal, and the even signal is st equal x negative t. We know that, am I right? For the even signal, the ak should equal a negative k. Am I right? This even signal is any signal, not only the real signal. Am I right? For the out, we call it even fs coefficient. For the out signal, which means xt equal negative x negative t, and ak equal negative a negative k, we call it odd fs coefficient. And the real even, for the real even signals, we have this one, and the fs coefficient have this relationship, and the which means the fs coefficient will be real and even. Why it is even? Because this one equal this one. Why it is real? Because this one equal this this one equal this one. Yeah. Yeah, just yeah. Okay. For the real and odd signals, and we have this properties for the fs coefficient, which means the fs coefficient is imaginary and odd. Yeah, you can see this, why it is imaginary, because this one equals this one. Why it is odd? Because this one equals like this, yeah, this one equals this one. Yeah, why it is imaginary? Because this one equals this one. Why it is odd? Because this one equals this one. That makes sense to you? Yeah. Actually, you don't need to remember it because, yeah, like spend much time on that. But for these properties, actually, you can easily to tell what kind of signals you are dealing with based on the fs coefficient. If you find out your fs coefficient have this relationship, which means your signal is real and even. if you find your like signals have these properties, FS coefficient have these properties, and which means your signal is real and odd. Yeah, and usually like for the symmetric properties, we just we not just we only use those two and let you tell what kind of signals you are dealing with. Yeah, but did you notice that? Yeah, all the like most signal we are dealing with is just real signal. Yeah, because the real signal is easier for us to deal with. Yeah. Okay. And any questions for the symmetric property? Okay, let's try to talk about linearity and time shifting. The linearity is just like we have two different periodic signal. And for those two different periodic signal, we have the FS coefficient, the separate FS coefficient separately. And then if you have a new signal, this one, and then you can easily get the new FS coefficient with this property. Does that make sense to you? Yeah. Actually, this linearity property is very common to use. Yeah. And time shifting, which means if you have a signal and the FS coefficient is AK, and then after time shifting, and you can easily get the new FS coefficient for the new signal. Yeah, using this, we call this part linear shifting, linear phase shift, because this is just related to the phase shift. Yeah, we know like the AK has two different parts related to the two different parts. One is magnitude, the other is phase. Am I right? So this one is just try to do a linear phase shift. Yeah. Any questions? Okay. And then let's try to review differentiation and integration. Yeah, the similar thing. If we have a periodic signal and its FS coefficient is AK, and then we have a new signal. This new signal is just derivative of the original signal. And then for the new FS coefficient, we have this relationship with the previous FS coefficient, which means you just multiply this part to the original one. Yeah, and then you got the new FS coefficient. Yeah, and for the integration, yeah, we know like the integration signal is all, which means we after integration, if we want to get the FS coefficient, it must be periodic. Am I right? We just talk about the periodic signals. Yeah, only periodic signal has a FS representation. Yeah. Okay. Then let me ask you a question. Why is the A naught equal 0? We talk about that. A naught, what's A naught? A naught is when k equals 0, it is related to the previous signal, am I right? Yeah, is the previous signal, the FS coefficient when k equals 0, am I right? Why it must be 0? Because you can see, okay. Yeah, we have this xt should, if you represent the xt, you can represent xt with this thing, with this equation. Do you know why? Actually, we know like the any periodic signal can be represented as a sum of series sinusoidal signal, am I right? So this is just a sinusoidal signal, am I right? This is sinusoidal signal, am I right? Yeah, actually, it's just a function of a sinusoidal signal, am I right? And if you add A0, what does that mean? Yeah, which means if we have a signal, this signal is periodic signal. Maybe it's not this, now have, this one is a beautiful signal because it's very simple, but maybe complicated, but we can consider it an example. If this is your like xt, right? If your xt plus 2, what does it mean? Are you sure? Shift left, huh? If yeah, shift left, right, which means you will change the t, right? But now I didn't change the t, I just changed the whole signal. What does that mean? Which means it will shift up or down because the value will multiple 2, am I right? Not multiple, plus 2, am I right? So your signal maybe comes like this. That makes sense to you? That makes sense to you? So if this signal is periodic signal, does this signal still is this signal still periodic after you up? Yes, all right. So which means this A now, even for if you add A now, it's just like a change the magnitude. That makes sense. But it never affect if it is periodic or not periodic. Am I right? But if you integrated xt, for example, if you use this is still like the xt, am I right? It's a periodic thing. Am I right? Yeah. If this is a periodic signal, it's just a single pseudo signal. Am I right? After you integrated it, do you? I think you learned this. You integrate the sin and cosine, you still get the sin and cosine. Am I right? But if you like integrated a constant number, constant. Yeah. What?
Bringing another variable.
Yeah. Yeah. Which means, for example, the xt has this this is the A, am I right? A, am I right? If you integrated A, what does that mean? Which means here, for example, we go from negative infinity to positive, from 10 to negative 10 to 10, which means for negative 10, for example, this is 1, am I right? This is 1, am I right? And negative 9, it will be 2, am I right? Negative, it will become this one. That makes sense to you? So this, if your send signal plus this value, your signal will become, yeah, here just add a 1, but as time pass, it will add more, and your signal will become this one. That makes sense to you? Is this periodic? No, yeah, because you can see, yeah, it changed the periodic. That makes sense to you? So which then if you want to, after you integrated the signal, it's still periodic, which means this item must be 0. Am I right? If there is no this one, if there is no like your signal is just related to sense and cosine function, am I right? Yeah, that makes sense to you. After you integrate it, it's always periodic because after integrated sin and cosine, it's always sin and cosine. That makes sense to you? So that's the reason why this must be 0. And then this for the new signal, this new signal is just after integrated the previous. And for the new fs coefficient, you have this equation. Yeah, it's just a multiple this to the original fs coefficient. That makes sense to you? And here you need to pay attention. ck must be equal 0. Yeah, do you know why? Because you can see for the xt, it's all sin and cosine, right? After you integrated it, it's always sin and cosine, right? There is no constant value anymore, right? Even you integrated sin and cosine, it's always sin and cosine. There is no like a constant value. So which means because C0, sorry, I think this is C0, 0, sorry. Just I will modify that. This is C0, 0 will equal 0 because there is no constant value. That makes sense to you? Okay. Any questions so far? Okay. And then let's review some examples. Yeah, actually, these examples are also homework. And before we review some examples, we review 2 often used FS pairs. You need to remember those 2. And if we have midterm 3, just put those 2 in your cheat sheet. Yeah, what are the FS coefficients for those 2 signals? Do you remember? For the first one, yeah, this is just a signal representation. And the FS coefficient, do you remember? It is 1 over t. Yeah, and how can you get this? It just use equation, like a signal analysis equation. You can get this. Yeah, we have already proved that. But yeah, if you forgot it, you can review. And for the second equation, do you remember? Yeah, the A now equal to T1 over T, and the AK is the other equation. Because for the A now, we cannot use this equation because K cannot be 0, right? So you need to separate calculate A now. And the A now is just this set area divided period. You remember we talked about, yeah. And then let's talk about this equation. Actually, this we talked about last class and the class before last class. And you can see here, for this equation, for this question, you can use this equation. Am I right? What's this equation? Do you know? Actually, if you want to get the AK, what equation you can use? If you use the equation, signal analysis, am I right? So this is just a signal analysis equation. And then for these equations, you just put t equal to this equation, am I right? And then you get this one. Yeah, because 2 pi over 2 is just a pi. Am I right? And then this equation equal this equation. That makes sense to you because you just put this part into the derivative and you put this outside. Any question? Yeah, maybe there is a little confused for you. And see, let me talk about the D, E, J pi K.
Oh, it's because you took it relative to the t.
Yeah. After it's just like a negative but it's just the negative J K pen E J negative K pen T dt. Am I right? Yeah, no dt. Yeah, it's just this one. Am I right? Yeah. So you can see if you just put it, you just like divide this one and then put it inside. Yeah, any question? Yeah. And then for this part, here, for this equation, actually you have this one. Yeah, this you must learn in some class, mathematics class. I don't know which mathematics class you learn, but you must learn this one. Integration by parts. If you have this one, and you have this, use this equation. And using this equation, you can get this one. You can get this one. Am I right? Yeah, and then step by step for this part, and you get this result. And for this part, you get this result. And then you will find this part actually is equal 0. And then just put this back to the equation. You get this one. And finally, your AK equal this one. That makes sense to you? Yeah, it's just and then you will find it's quite complicated, am I right? Yeah, it's not easy for you. Yeah, am I right? So we have the other method. You can see for this signals, we know that the period is 2 and the inner equal 0. Am I right? Because the inner equal like sand area divided period, and you will find if you derivative this equation, you can get this one. Do you know why? You know, let me expand it for you. I need to expand it. Yeah.
It's just the slope of it.
Yeah, you can see for the slope, every slope it will same, am I right? Yeah, so it is just a constant, am I right? But for this step, we know it will be an impulse, am I right? Yeah, you know that, am I right? Yeah, because it's from positive to negative or one. It's just it's just a decrease, am I right? So it's just this one. It's just 2. That makes sense to you? Yeah, actually, then we will have you can see if this is just a constant, am I right?
I think it's like pull down basically.
Yeah. Pull down basically, yeah, because you can see if you derivative this one, actually it will go to infinity. Yeah, but the area will be 2. Yeah, because it's
why there's not breaks on the platform. There's not any breaks, and then it's still that same rate, even though it's being.
Yeah. That's right. Yeah, you can see this part is just a constant. Here is just the impulse. Here is just the impulse, but the other part is just a constant. That makes sense. Your slope are all the same. Am I right? Yeah. Okay. And then for this one, the constant actually we can ignore that because the constant is only affect the inner, like the for the fs coefficient, it just affect the c naught or e naught like that, and we just need to focus on this part. Yeah, but if we want to find the fs coefficient for this part, do you know which fs pairs we can use, like too often used? fs pairs. Yeah, that one, this signal, am I right? Yeah, but you can see if we want to get this signal, we need to change this one, am I right? To try to like in reverse, try to shift, am I right? Yeah, for this one, you can see the original one is just like a 0, am I right? But here it is should be 1, am I right? Yeah, so then this is just like the AK. So then HT should equal 1. Do you know how this 1 come from? Because this thing is a constant value, am I right? But here, this GT minus 1 is just a left shift, right shift to right shift 1 unit, am I right? Just like this, am I right? And then you can see multiple 2 because the area is 2. That makes sense too. And then because why there is a negative? Because it's flip. So the HT equals this one, am I right? Yeah. And then here, actually, this constant, like a term, only affects C naught or E naught. Yeah. So we don't need to consider that for the CK. Yeah, because for the CK, we know like the G. Here we also use the shifting property because we have the GT like a FS coefficient for the GT. Am I right? And here is GT minus 1. Am I right? So we need to use this equation. Any question? Yeah, if here we want to find the CK, am I right? Yeah, so for the CK, and we mainly focus on this part. That makes sense to you? And for this part, we have the GT, the FS coefficient, 1 over T, am I right? But here, if we want to get this one, we need to shift firstly. And for the shift, we have this equation, am I right? So, which means for the CK, we have negative 2 multiple BK like multiple E, G, K, G, K, pi, because here the parity is 2. That makes sense to you? Yeah, and then the BK is what? Do you know? It is obvious, am I right? The BK is just the GT's FS coefficient, am I right?
Did not flip or exponent to be positive.
You mean this one is negative 2? You mean
T naught top be negative 1, would that not flip the sign?
it's not flip the sign? What does it mean?
Start T naught's negative 1 and it starts as a negative JK, but then not flip it to be positive JK by.
Why it will be flip?
To be like negative JK, like based off the.
Yeah, because here is negative GK, am I right?
So when we plug in our T naught be negative 1.
No, the T naught should be this one, am I right? Yeah, but here you can compare this one to this one.
Oh.
The T naught is just 1.
T naught.
Yeah. Just pay attention because it's many students just confused with this one. Yeah. So this is and it makes sense, am I right? So here BK actually is just this one. That makes sense to you?
So if it was like a left shift.
Yeah, left shift. Yeah. So which means the CK is just this one, am I right? And then the K should now equal 0 because you need to separately consider that. Am I right? Yeah. Okay. And then let's talk about how to get AK, because you can see the CK is just like you try to derivative it. Am I right? And if you want to find AK, which means the XT should integration HT equal XT. Am I right? Yeah, because you can see the HT equal XT derivative XT, am I right? And then we know like the XT should equal integrated HT. It is the opposite like operation. Yeah, that makes sense to you? Yeah. So for now we have the CK, am I right? If we want to find an AK, we should use the integration, am I right? That makes sense to you because after integration, here the CK, this AK becomes CK, and this become AK. That makes sense to you? Yeah, so which means we need to multiply this part to the CK. That makes sense to you? Yeah, so then, yeah, then we have EK equal this one, multiple this part. That makes sense to you? Yeah, and then we have this one. Simply, simple that we have this one. Yeah, and the CK, yeah, you know that it equals this part. Yeah, that makes sense to you? Okay, any question? Okay, then let's talk about the other one, this one. What's the period? I think we have already talked about. Just a quick review this one. Period is 6. Yeah, and what's the A now? 1/2 because yeah, it's an area, set area. And then you can see if you derivative xt, what you can get? Do you know? Yeah, if you derivative xt for this one, this is the slope, right? This is the length. The derivative value should be the slope. Yeah, square wave, because this one should be 0, right? And this one should be the other value. So you can see it should have this one. Because you can see this one, you get a value, and this one is negative. Yeah, because it's yeah, and for if you derivative this one, it's just 0, right? Okay, which FS pairs you will use? Yeah, the second one, this one, and we will use this one. Yeah, for the GT, the BK equals this one. Am I right? Yeah, but if you want to get the HT, you need to use GT to represent that HT. Am I right? So then here we know like the T equal we know here T equals 6. Am I right? And the T1, yeah, because the total is 1, so the half is 0.5. That makes sense to you? And then you can see the HT should equal this one. Because you need to shift it right 1.5, am I right? And the right 1.5, you get this one, but it will flip. So you add a negative, am I right? And if you like left shift 1.5, this one, and you get this one, am I right? But yeah, there you don't need a flip, so you get this one, right? Then what properties you will use? Yeah, you know this one, and if you want to find the FS coefficient for this one and this one, what do you get? What properties you will use? Shifting properties. That makes sense to you? Yeah. And yeah, and then this is just if we similar thing. If we want to find the AK, you just divide this one, am right? Because this is just integrated back. Yeah. So this is just for the AK equals CK divide this one. For the CK, yeah, you just use this property. Yeah, and for this part, if you find a T minus 1.5, which means T now equal 1.5, right? And for this part, actually the T now equal negative 1.5. Am I right? So, like you said, you need to flip. Yeah, you need to remove that negative symbol. That makes sense to you? Yeah. Okay. Just this is homework. Just try to finish it by yourself. Okay. Let's try to. Yeah. This is just simplify that. Let's try to review the other one. For this one, what's the period? Oh, sorry. For this one, what's the period? Are you sure? Huh? 3, yeah. The A now equal 1, am I right? Yeah, just the area. And then you can see, this is if you this is after you derivative this one, you get this one. Am I right? Yeah, because you can see this is just like this value, and this one is just a negative value. So positive value, negative value, because the slope is the same thing. Am I right? That makes sense to you? Any question? No? Okay. And then which FS pairs we should use? Do you know? First one or second one? Yeah, actually you can see it's square. Am I right? It has a square. Huh?
Could use both.
Actually, you can see for the first one, only let's do a summary. Only you have the impulse, you will use that one. If there is no impulse, you don't need to use that one. Yeah. So yeah, so for the we should use second one. And then let's talk about that. How then you will need to use GT to represent HT, right? And then let's try to do a move. Yeah, you can see for this one, maybe for this one, it's difficult for you to tell how to represent the HT with GT. But for this one, you can see, you can easily to find, right? And for this one, you can see the from T1, negative T1 to T1, it is 2, right? Which means the T1 should equal like here, it should be equal 1. This is negative 1. That makes sense to you? Yeah, and the period is just 3, right? So if you want to get this one, which means you just try to move from here to 1, from this is negative 1 to 1, right? Which means you just right shift 2 units, right? That makes sense to you? And then this is 1, right? But here, this is 2. This is 3, right? So you need to multiply 3. That makes sense to you? And then you can see, you get this one. And if you, but this is not HT, right? HT is just this one, which means you need to down minus something, right? So yeah, this is what you will get. Yeah. And you just try to move it to left, 2 units right. And then multiple 3, because this is the value of 3, and then down 2 units. That makes sense to you? And if you get this, you can easily to find the FS coefficient for this part based on this one. Am I right? Yeah, just use shifting property. And the like we said, the constant value doesn't matter. That makes sense to you? Yeah. And then you use this integration properties to get the original FS coefficient. That makes sense to you? Okay. And actually, for this question, we have the other method. You can see this is that HT, right? If you down move this one, you can get this equation. You can get this signal, right? If you for this signal, what's the T1? If you want to use for compare this one to this one, what's T1? Are you sure? Yeah, you can see.
Yes, so.
0.5, right? Yeah, because the whole is 1, right? So the one T1 will be 0.5, right? And then you can see you just need to move from 0.5 to 1, which means you just right move 0.5 unit, right? But here is up, here is down, right? So you just flip it, -3, right? That makes sense to you? So you have this one. Your HT should equal like a right shift 0.5, and then multiple -3 because it's flipped, right? And then because you need to up 1 unit, right? Yeah, if you want HT, and then you have this equation, right? And for this one, it's also easy to get based on the shifting property. And after you get the CK, you can use to get VK. That makes sense to you? Yeah. So this is how all the properties use. Yeah, it's very important. If you have any questions, just let me know. Okay, let's try to summarize. For this kind of equation, you try when you get the original signal, try to find which signal, which FS pairs you need to use. Like the first one or the second one, the impulse one or the square one, and then you try to find the HT. Usually the HT will be the derivative of XT or integrated XT. And then after that, you just get the FS coefficient for HT, right? And then this is just like from BK, you can get a CK. From CK, you can easily get AK based on all the properties. That makes sense to you? Okay, any questions so far? Okay, and then let's talk about, yeah, actually, this is just a map T from FX coefficient to a DT signal. Yeah, you can see, actually from a set of FX coefficient AK, you can you can represent this fs coefficient with a dt signal. Actually, you can see, let's try to, maybe this one is very object. Let me give you an example. For example, this is our fs coefficient, am I right? The a1 equal, a negative 1 equal to a1 equal negative 2, a now equal 1, and the other is just 0. And you can see, you can draw it. Yeah, this is, if you draw it, this is your ek, am I right? Yeah, that makes sense to you? Yeah, this is just a 2, this is just a negative 2, this is just 1. Actually, did you notice the why we call the fs coefficient? We also call it fs pairs or something. You can see for the fs coefficient, it always pairs. Did you notice that? If you have a negative 1, there must be a1. But sometimes it will equal, sometimes it will be conjugate. Yeah, like sometimes, yeah, it depends. But if you have a negative 1, you must have a1. If you have a negative 2, you must have a2. Yeah. So this is AK, right? Actually, we can use the DT signal to represent AK. Do you know how? Do you know how? Yeah, you can see we can represent this is negative 2, negative 1, 2. Yeah, actually, we can use the DT signal to represent this one. That makes sense to you? Yeah, this is just when the k equal negative 1, it will be 1. Right? This is when the k equals 0, it will be 1. Yeah, this is just 1, this is 2, it's negative 2. That makes sense to you? Yeah, and then you can see we can use this equation to represent it. That makes sense to you? Yeah, okay, and then actually from a DT signal, also you can represent a set of fs coefficient. Yeah, yeah, you can see if you have this one, ak equal to this equation. Can you tell me what's a negative 3? Yeah, 0, right? Yeah, because how about a negative 2? Yeah, it's 2. How about like actually first like a2? Yeah, a negative 1. Yeah, a negative a1. Yeah, a0. Yeah, yeah. If you have this equation, you also can easily get fs coefficient. Yeah, that makes sense to you. Okay, and then let's try to review the multiplication. The multiplication actually is this. You can define it like this. If you have two periodic signals, and those two periodic signals, the fs coefficient is this one, and then yeah, those periodic, and then there is new signal xt multiple yt. And for the new fs coefficient, it has this equation. Yeah, the new fs coefficient you can use ak and bk, get the new fs coefficient, but it's using this equation. Are you familiar with this one? This one? What's this? What's this? Are you familiar? You know what's this? Actually, it is dt convolution sum. Yeah, am I right? Yeah, if you remember that, it is just equal AK multiple convolution with BK. That makes sense to you? Yeah, okay. Yeah, it's just equal this one. That makes sense to you? Yeah, okay. So, which means the CK equal AK convolution with BK. Yeah, and then, yeah, we can use this to represent AK, this is represent BK, and this is represent CK, and the CK is just the fs coefficient for the new signal, and this new signal is xt multiple yt. Actually, for the fs, for the Fourier transform, we also have a multiplication properties. It's very useful for the signals and system like analysis, but we will talk about it later in chapter 4. Yeah, and yeah, this one we can. Let's talk about one example. For example, you have a signal xt, you have a single yt, and then zt equal xt multiple yt. And you can see it. Firstly, let's determine the fs coefficient for the xt, and then fs coefficient for the yt, and then we use this properties to determine the fs coefficient for the new thing, for the new signal, and then yeah, directly. Then let's try to determine the fs coefficient using the direct expansion in like a tree geometric form, yeah, the using that equation. We will talk about that. Yeah. Here we need to use this equation. Yeah, this equation I think you are familiar with. Yeah, and then let's talk about for the ST. Actually, if you use this equation, you can easily to find for the ST, you only have a negative one. Yeah, and so the AK should equal this one. Yeah, because you only have the fx coefficient A1, a negative one. There is nothing because you can say cosine for pi t, you just use this equation. You can see you only have two atoms, am I right? The two atoms it doesn't include any constant value, am I right? Which means the A now should equal 0, am I right? It's only have like a A1 and a negative one, am I right? Yeah, and then for the BK, actually it's the same thing because it's same. Yeah, it only have B1 and B negative one, so you have this equation. And then you get the new fx coefficient using this equation, am I right? And then you have this one, convolution with this one, am I right? How to calculate this one? How to use convolution properties, am I right? Yeah, we know many convolution properties, am I right? So then you want to remove the pairs, am I right? You want to make them together, am I right? So just use distributive and shifting, and you will get this one. All right. And then you can see this one and this one is the same thing. This part and this part is the same, right? So you can add those two together, you get this one. What does that mean? For the new CK, what's the C3? Yeah, 0. What's the C2? A1, B1, am I right? Like C2, am I right? The coefficient is A1, B1. That makes sense to you? Yeah, so this is just a C2. Yeah. This is just some number. Yeah. You can fix this is just try to represent it. Yeah. Okay. And then this is like C negative 2, right? This is what? Yeah, C0, am I right? Yeah. So there is no other atoms because the other atoms is 0. So this is C negative 2. This is C0. And this is C2. Am I right?
You can't get a 0 on them by themselves, put together.
Yeah.
Yes.
You mean there is no 0, but there is 0, right? Yeah. So it depends. It just depends on your calculation. Yeah. Not just because there is no 0, there must be no 0. Yeah. That makes sense to you? Okay. And let's try to verify it. Actually, you can see we know the ZT equal IC multiple YT, am I right? Hey, let's 2. Am I right? So we have this equation, am I right? And this equation, we know this equation. This is some basic cell equation, am I right? So which means ZT equal this one. All right? Yeah. And then we use the here equation, the equation here. And then we have this one. All right? Yeah. And then we have this one. All right? And then which means here t equal like -5, am I right? So omega equal 4 pi, and then this is C2 equal C negative 2 equal this one. Okay, what kind of signal we have? Yeah, actually you can see this one. If you find this one. Yeah, real and odd, you are right. Yeah, because they have this equation. That makes sense to you? Okay, then let's talk about the question you just asked before. You can see here, what's the signal? What's the signal? 0, am I right? And then here, we have the equation here, am I right? What does that mean? Which means this part equals 0, am I right? See, so usually, it depends. If this is not 0, which means you have the 0 atom. constant atom. But if this is 0, which means you don't have the constant atom, it depends. That makes sense to you? Okay, and then let's try to talk about the NASA FS properties. Yeah, firstly, we just try to review. This is a signal synthesis equation, and this is a signal analysis. The time reversal, which means if you have x negative t, and then you will find the fs coefficient will equal this one. Actually, I think this one is just very similar with this one. That makes sense to you. The bk equal a negative k. I'm right. Yeah, the time reversal is just like if you have if you have x negative t, then your ak, your fs coefficient is just this one. And then for the conjugate, if you have fs coefficient ak for the xt and the xt conjugate, actually you have this equation. Conjugate t equal the fs coefficient to this one. You can this is just how to prove that. And then time scale, if you have the new signal is x alpha t, which means you just try to multiple, because here should be alpha t, right? And then you will find the ak is the same thing, am I right? Only here change. What does that mean? Which means the new signal, the fs coefficient will be same. It's still ak, am I right? Yeah, but the period and the frequency will change for this new signal. That makes sense to you? Okay. Any question? Let's try to talk about one problem. Yeah, for this one, xt, there are some signals. For the first one, what's the fs coefficient? Yeah, this is just like the properties we just talked about. And then for the first one, what's the fs coefficient? It just use this one, am I right? This is the first property, shifting property, am I right? Which means you can easily get the new fs coefficient is this one. That makes sense to you? Yeah, and for the b, if you use the Euler equation, you can get this one. That makes sense to you? Okay, and then for the even part, we can get this equation, am I right? And for the fs coefficient, we know this is dk, am I right? And we know this is a negative k. That makes sense to you? And then linear properties, we know the fs coefficient should be this one. That makes sense to you? And for the real part, we know the real part is this one. And then we can easily get the fs coefficient, this one. That makes sense to you? Okay, and for the derivative, we know that the derivative, after derivative, you have this one, right? And then you can see, that derivative, you can get this one. Yeah, so this is a new fs coefficient for the new signal. That makes sense to you? Okay, and this is today's class, and we will do a summary on Friday. Yeah, and if you have any questions, let me know. Okay. How about the homework? Do you have any question? No? No question? Okay, that's great.